Question 1. For each analytics category, drag it to the appropriate description. Each item may be used once, more than once, or not at all. Summarizes what happened using historical data and KPIs. Descriptive analytics investigates why an outcome occurred by probing anomalies and related data. Diagnostic analytics forecasts what is likely to happen next using historical patterns. Predictive analytics recommends which action to take to achieve a target under uncertainty. Prescriptive analytics simulates human intelligence to process large datasets with minimal intervention. Artificial intelligence, AI. Now let's go through the explanations together. Descriptive analytics helps us understand what has already happened. For instance, when a company analyzes past sales reports to summarize performance or track KPIs, it's using descriptive analytics to describe outcomes. Diagnostic analytics, on the other hand, digs deeper to explain why something happened. Think of it as investigating anomalies or patterns in customer behavior to uncover causes behind drops or spikes in performance. Next, predictive analytics uses data trends and models like regression or neural networks to forecast future outcomes. For example, an e-commerce site predicting next month's demand based on historical sales. Moving on, prescriptive analytics takes those forecasts and recommends what to do next. It might suggest pricing adjustments or marketing strategies to meet targets despite uncertainties. Finally, artificial intelligence, AI, simulates human intelligence to process data automatically and generate insights with minimal human input. It can recognize patterns, provide recommendations, or even generate visual insights from large data sets. So each category builds upon the previous one, forming a hierarchy of understanding, from describing the past to predicting the future and finally recommending intelligent actions. Question 2. A manufacturing company wants to understand why its equipment maintenance costs have risen. The data team identifies unusual cost spikes, gathers related metrics, and applies statistical models to explain the cause. Which type of analytics are they applying? So one answer: A, prescriptive analytics, B, predictive analytics, C, diagnostic analytics, D, descriptive analytics. The correct answer is C, diagnostic analytics. Now let's go through the explanation together. Diagnostic analytics focuses on uncovering why something happened. In this case, the company is examining unusual cost spikes, collecting data, and applying statistical methods to find the relationships that explain the rise in maintenance costs. Meanwhile, descriptive analytics would simply summarize what happened, for example, reporting that costs increased last quarter, but without explaining why. On the other hand, predictive analytics would try to forecast future maintenance trends rather than analyze past causes. And finally, prescriptive analytics would take things further by suggesting what actions to take to reduce future costs. So because the focus here is on understanding the cause behind rising costs, diagnostic analytics is the most appropriate method. Question 3. For each statement below, indicate whether the answer is true or false. Reports act as the primary medium for communicating analytical stories. True. Data analysts help organizations handle overwhelming amounts of data. True. Limiting access to analytical results improves collaboration. False. Analytical reports are meant to confuse rather than clarify information. False. Now let's go through the explanations together. Reports act as the primary medium for communicating analytical stories because they turn analytical findings into clear narratives that business users can understand and act on. Next, data analysts help organizations handle overwhelming amounts of data since they convert complex data into structured insights, making it easier for decision makers to see patterns and take informed actions. However, limiting access to analytical results does not improve collaboration. In fact, it restricts teamwork and knowledge sharing, weakening an organization's ability to make collective, data-driven decisions. Finally, analytical reports are meant to clarify, not confuse information. Their purpose is to make data meaning transparent and actionable, not to obscure it. Question 4. Fill in the blanks by selecting the correct options from the drop-down menus. Data analysis supports critical decision-making by transforming raw information into meaningful insights that are useful for guiding business actions. Let's unpack this step by step to understand why each choice fits perfectly. Starting with critical decision making, the core aim of data analysis is to give leaders a factual base for making sound business choices, rather than relying on intuition or guesswork. Then comes raw information, which refers to the unprocessed data that forms the starting point of every analysis: numbers, logs, and inputs that are yet to be organized. Through analysis, these data points are converted into meaningful insights, allowing organizations to uncover the story behind the numbers. Those insights must be useful, meaning they provide practical value and can actually influence decision making rather than just exist as abstract findings. Finally, all of this contributes to business actions, where the insights guide what steps to take next, whether it's adjusting strategies, improving operations, or boosting efficiency. In essence, data analysis transforms scattered information into structured intelligence that drives purposeful and effective business moves. Question 5. A company's analytics team is expanding its architecture. They already use a lakehouse, but want an additional storage layer optimized for structured reporting. They assign someone to prepare and maintain this new store while continuing to manage semantic models and ensure data quality for self-service analytics. Which role is best suited for this task? Select one answer. A. Analytics engineer. B. Data engineer. C. Business analyst. D. Database administrator. The correct answer is A. Analytics engineer. Let's explore why this role fits so well. An analytics engineer bridges the gap between data engineering and data analysis by building and managing analytical data stores such as warehouses and lakehouses. They ensure data accuracy, maintain semantic models, and make sure analysts and stakeholders have clean, trusted data sets for reporting. While a data engineer is more focused on creating pipelines and setting up the infrastructure that moves data, they usually don't handle the modeling and reporting layer designed for self-service analytics. A business analyst interprets the data for decision-making, but doesn't manage storage layers or ensure data quality at the system level. Finally, a database administrator maintains database performance and security, not analytical modeling or reporting enablement. In short, the analytics engineer takes ownership of transforming data into a structured, high-quality format ready for insight generation, making them the perfect fit for this scenario. Question 6. For each statement below, indicate whether the answer is true or false. A semantic model includes data, transformations, relationships, and calculations. True, Power BI reports can include multiple pages built with visuals. True, Power BI dashboards contain multiple pages for detailed exploration. False, tiles in a dashboard are interactive within the dashboard page itself. False. Let's walk through the reasoning behind each statement to make sense of it all. Starting with the first statement, it's true, because a semantic model serves as the foundation for structured data in Power BI. It integrates datasets, defines relationships, applies transformations, and performs calculations to prepare data for accurate reporting. The second statement is also true. Power BI reports are flexible and can have multiple pages, each showcasing different visuals or aspects of analysis, much like a multi-page document. However, the third statement is false, because Power BI dashboards are single-page summaries. They consolidate key visuals pinned from reports, but don't allow detailed exploration within the dashboard itself. Finally, the fourth statement is false, since dashboard tiles are static snapshots. They aren't directly interactive on the dashboard, but link back to the interactive visuals in their source reports. In essence, reports are where users explore and interact with data deeply, while dashboards act as concise overviews of the most important metrics. Question 7. In what ways do analytics engineers differ from data engineers? Select two answers. A. They alone manage all machine learning experiments. B. They primarily own operational database tuning and backups. C. They focus on modeling curation in lakes or lakehouses and create semantic models in Power BI. D. They sit closer to business reporting and self-service enablement. The correct answers are C and D. All right, let's break down why these two are the right choices. Starting with C, analytics engineers specialize in building the bridge between raw data and business insights. They handle modeling and curation within data environments like lakes or lakehouses and are responsible for creating semantic models in tools such as Power BI. These models make complex data sets more accessible and easier for business teams to use. Moving on to D, analytics engineers also sit much closer to the business side compared to traditional data engineers. Their work directly supports reporting and self-service analytics, enabling teams to make data-driven decisions without needing constant technical assistance. In contrast, data engineers focus more on building pipelines, ensuring data movement, and maintaining infrastructure, while database administrators handle tuning and backups, and machine learning is the domain of data scientists. So in essence, analytics engineers combine technical precision with business understanding, ensuring data is both reliable and ready for decision-making. Question 8. When publishing a Power BI report, what must a user select before the report is uploaded to the Power BI service? Select one answer. A, a data gateway. B, a dashboard layout. C, a workspace destination. D, a refresh frequency. The correct answer is C, a workspace destination. Here's how this works in practice. Before a Power BI report can go live in the Power BI service, it needs a workspace destination, essentially the digital folder where the report will reside. This workspace serves as both the storage and organizational hub for reports, datasets, and dashboards, ensuring proper access control and version management. In contrast, a refresh frequency is configured only after publishing when scheduling data updates. A dashboard layout doesn't come into play until visuals from the report are pinned later to create a dashboard. And a data gateway simply manages secure connectivity between on-premises data sources and the Power BI cloud, not the publishing process itself. So, selecting the workspace destination is the key step that determines where your report lives and who can access it once it's published. Question 9. Which statement best describes the relationship between Power BI Copilot and Fabric data agents? Select one answer. A. Copilot and Fabric data agents cannot be used in the same environment. B. Fabric data agents are used only for visual formatting. C. Both use AI, but Copilot focuses on assistance while Fabric data agents handle custom data tasks. D. They are identical and interchangeable. The correct answer is C. Both use AI, but Copilot focuses on assistance, while Fabric data agents handle custom data tasks. Here's how to understand the difference clearly. Both Copilot and Fabric data agents are powered by AI, but they serve very different purposes. Copilot acts as an intelligent assistant, guiding users through tasks, generating insights, and helping automate repetitive steps in Power BI through conversational commands. Meanwhile, Fabric data agents specialize in handling custom data workflows, such as executing scripts, managing processes, or integrating external systems within Microsoft Fabric. They operate more like automated executors than assistants. They are not identical or interchangeable, since Copilot supports the user experience layer, while data agents manage the operational side of data handling. And yes, they can coexist within the same environment, working together to enhance efficiency. In short, both leverage AI, but Copilot empowers users, while Fabric data agents empower the data itself through automation. Question 10. Tailwind Traders stores financial projections in AAS and actual sales in a relational database. You must compare both while keeping measures and security centralized in AAS and showing updates immediately when AAS refreshes without scheduling a separate Power BI refresh. What should you do? Select one answer. A. Import the AAS model into Power BI and schedule refresh there. B. Use Connect Live to AAS for projections and combine with sales via the report. C. Export AAS tables to CSV and import them. D. Duplicate AAS measures inside Power BI and use direct query to AAS. The correct answer is B. Use Connect Live to AAS for projections and combine with sales via the report. Let's unpack why this approach is the smartest one. By using Connect Live to AAS, Azure Analysis Services, Power BI reports remain directly linked to the AAS model. This means all data, measures, and security roles stay centralized in AAS, and any refresh that happens in AAS is instantly reflected in Power BI. No extra refresh scheduling needed. This setup ensures real-time accuracy while maintaining governance and performance efficiency. On the other hand, importing the AAS model would create redundant copies and break the live connection advantage. Exporting to CSV would turn your data static, losing timeliness and governance. Duplicating measures with direct query would undermine AS's role as the single source of truth and add unnecessary complexity. So the ideal solution is to connect live, allowing Power BI to tap into fresh AS insights dynamically while blending them with relational sales data for complete analysis. Question 11. A report developer notices that the December value in a column is misspelled as December and wants to correct it without altering the original file. Which Power Query action should be used? Select one answer. A. Replace null values. B. Replace values. C. Remove duplicates. D. Edit in Excel. The correct answer is B. Replace values. Here's the reasoning behind it. The Replace Values feature in Power Query allows you to fix specific text errors directly within the query editor without modifying the original data source. By targeting the incorrect spelling, December, and substituting it with the correct one, December, you ensure clean and accurate data throughout your report, all while maintaining the integrity of the source file. Why not the other options? Replace null values only fills blank or missing entries. It doesn't fix textual errors. Remove duplicates eliminates repeated records, not incorrect spellings. Edit in Excel would alter the source file itself, which goes against Power Query's transformation principle of non-destructive editing. So the smart and safe move is to use replace values, which keeps the original data intact while seamlessly correcting errors during data transformation. Question 12. For each statement below, indicate whether the answer is true or false. Changing data types in Power Query is preferred before loading to the model. True. Incorrect data types can block relationships and certain calculations. True. A date hierarchy is available even if the column is typed as text. False. Databases are less prone to type errors because data types are predefined. True. Let's walk through why these answers make sense. Changing data types in Power Query early in the process ensures consistency and prevents errors downstream. By setting types before loading into the model, Power Query applies transformations as part of its step-by-step logic, saving time and avoiding inconsistencies across refreshes. Incorrect data types can absolutely disrupt relationships and calculations. For example, if one table defines a date field as text, while another defines it as a date type, Power BI won't be able to form proper joins or calculate time intelligence functions like YTD or QTD. A date hierarchy only appears when a column is typed as a proper date or date time. Text values don't support hierarchical breakdowns like year, quarter, month, day because Power BI can't interpret text as temporal data. Finally, databases reduce type-related issues because they enforce schema definitions. Each table in view explicitly defines column data types, integer, date, string, etc., minimizing the risk of misclassification before data ever reaches Power BI. In short, clean and correctly typed data is the foundation for reliable analysis, and Power Query is the best place to make that happen. Question 13. Fill in the blanks by selecting the correct options from the drop-down menus. Power BI's initial type inference scans the first 1,000 rows by default. When a column is misclassified, use Power Query Editor to set the correct data type, which is stored as a changed type step and reapplied on refresh. Now let's take a moment to understand why each part of this question makes sense. By default, Power BI examines the first 1,000 rows of a dataset to guess each column's data type. This helps it quickly determine whether a column contains numbers, text, or dates. However, sometimes that limited sample can cause Power BI to misclassify a column if unusual data appears later. That's where the Power Query Editor comes in. It's the recommended workspace for cleaning and transforming data before loading it into your model. In this case, you would open Power Query, select the column, and assign the correct data type. For example, changing a text column containing dates into an actual date type. Once that adjustment is made, Power BI automatically records it as a changed type step. This means every time your data refreshes, Power BI reapplies that same correction without you needing to redo it manually. In short, using Power Query to define types early ensures accuracy, consistency, and proper data interpretation throughout your reports. Question 14. Arrange the steps to append 3 tables into a new master list. Cache instruction. Drag and drop the items into the correct order, starting with the first step at the top. Align and rename source columns so headers match across tables. On the Home tab, open the Append Queries dropdown. Choose Append Queries as new. Move the desired tables from Available Tables to Tables to Append, then select OK. Review the new query that contains all rows from all selected tables. Now, let's go through the explanation together. To append 3 tables into one master list, the first thing you need to do is align and rename the source columns so that all headers match. This ensures that when the tables are combined, data from each column goes into the right place. Next, you go to the Home tab and open the Append Queries dropdown. This gives you access to the tools needed to merge multiple tables into one. Then, you'll choose Append Queries as new, which allows you to create a fresh combined query rather than replacing existing ones. After that, move the desired tables from the Available Tables section to Tables to Append and click OK. This action confirms which tables will be merged together. Finally, review the new query to ensure all rows from the selected tables appear correctly and that the headers align properly. This logical sequence ensures a clean and accurate append process in Power BI. Question 15. For each Power BI import model capacity condition, drag it to the correct description in the correct match column. Each item may be used once, more than once, or not at all. Maximum scheduled refresh frequency in a shared capacity is up to 8 times per day. Shared capacity refresh limit. Maximum scheduled refresh frequency in a dedicated premium capacity is up to 48 per day. Premium capacity refresh limit. Dataset size limit in a shared capacity is 1 gigabyte. Shared capacity dataset size limit. Datasets can exceed 10 gigabytes in premium when large dataset storage format is enabled. Premium capacity with large dataset storage format. All right, let's break this down step by step so it's clear how each condition connects. When using shared capacity, Power BI restricts data refreshes to 8 times per day. This ensures that shared environments remain stable and fair for all users relying on the same resources. Meanwhile, in premium capacity, the refresh frequency increases dramatically, up to 48 refreshes per day. This flexibility supports enterprise users who need frequent data updates, such as organizations tracking real-time KPIs. Next, the dataset size limit plays a major role. In shared capacity, datasets are limited to 1 gigabytes, which is suitable for small to medium scale reports. But once your data grows beyond that, you'll need premium to scale. Finally, when you enable large dataset set storage format in premium, datasets can easily exceed 10 gigabyte, offering enhanced for massive data models. So while shared capacity focuses on efficiency and control, premium delivers scalability and advanced refresh power for larger data-intensive environments. Question 16. Which statement best captures compatibility between Azure Analysis Services and Power BI models? Select one answer. A. AAS requires MDX only. Power BI models cannot reuse those calculations. B. Power BI models are relational only. AAS is multidimensional only. C. Compatibility is limited to metadata. Measures must be rewritten in Power BI. D. AAS tabular models use DAX, making them compatible with Power BI's tabular engine. Let's explore why option D is correct and how it connects both systems. Both Azure Analysis Services, AAS, and Power BI rely on the same underlying DAX formula language and tabular engine architecture. This shared foundation allows seamless reuse of measures and smooth live connections between the two platforms. In contrast, the idea that AAS requires MDX only is outdated because AAS supports both MDX and DAX. Similarly, Power BI is not limited to relational models. It also uses the same tabular structure that stores relationships and calculations. Moreover, compatibility is not confined to metadata alone. Since both systems use DAX, the measures built in AAS can be used directly in Power BI without any rewriting. In summary, because AAS tabular models use DAX, they integrate naturally with Power BI's tabular engine, ensuring consistency and efficiency when modeling or reporting across both platforms. Question 17. Your organization prohibits data from leaving on-premises systems. A report must always query current records in a SQL Server database, and the database already enforces row-level security for users. Which two approaches align with these constraints? Select two answers. A. Import the data into Power BI and recreate RLS rules in DAX. B. Use a direct query model that connects to the on-premises database through an approved gateway. C. Implement single sign-on SSSO so the source database's RLS rules apply at query time. D. Export daily CSV files to OneDrive and connect to them on a schedule. The correct answers are B. Use a direct query model that connects to the on-premises database through an approved gateway. And C. Implement single sign-on SSO so the source database's RLS rules apply at query time. Here's why these two options make perfect sense. When data must stay within on-premises systems, Direct Query provides a secure connection model that never moves data into Power BI. Instead, every query runs directly against the SQL Server using a gateway, ensuring compliance with the no data leaves premises rule. At the same time, enabling single sign-on SSO allows the user's identity to flow through Power BI to the source database. This ensures that row-level security RLS rules are applied automatically at query time, preserving the same access logic users have in SQL Server. On the other hand, importing data or exporting CSV files to OneDrive would break the security model, as data would be duplicated outside the protected environment. So, combining Direct Query with SSO provides real-time, secure, and compliant reporting while maintaining full data governance. Question 18. Fill in the blanks by selecting the correct options from the drop-down menus. Each column in a DAX model has a data type, which defines the kind of values it can store. Let's break this down for better understanding. Every column in a DAX model must have a data type, which tells Power BI how to store and interpret its contents. For instance, a column defined as a date type can support calendar-based operations such as month comparisons or year-to-date analysis, while a numeric type allows aggregations like sums and averages. In addition, the kind of values describes the category of data that the column can hold, whether it's numbers, text, or dates. Essentially, the data type determines how Power BI handles the data, while the kind of values defines what that data actually represents. By setting these correctly, your DAX model becomes more efficient, accurate, and easier to maintain during report creation. Question 19. For each DAX operator type, drag it to match its correct function. Each item may be used once, more than once, or not at all. Perform calculations such as addition, subtraction, multiplication, and exponentiation. Arithmetic operators. Compare two values to return true or false. Comparison operators. Join two or more text strings into one. Text concatenation operator. Combine or test Boolean results using and, or, in, and not. Logical operators. Determine the order in which multiple operations are evaluated. Operator precedence. Let's take a closer look at how each one works in DAX. Arithmetic operators handle basic mathematical operations like addition, plus, subtraction, nice, multiplication, sod, division, and exponentiation, allowing you to perform numeric calculations within measures or calculated columns. Comparison operators are used to check relationships between two values, such as equals, greater than an, or less than dan, and they return a true or false result. Next, text concatenation operator uses the ampersand symbol and to join text strings together, which is useful for combining columns like first and last names into a single field. Moving on, logical operators such as and, or, and not help test multiple conditions in a single expression and making it possible to apply complex filters or branching logic. Finally, operator precedence determines the order in which DAX evaluates these operations, ensuring accurate results in formulas that mix multiple operator types. Understanding these operator types ensures your DAX calculations execute exactly as intended, with consistent, predictable outcomes across your reports. Question 20. For each statement below, indicate whether it is true or false. When the earliest and latest dates in model data don't align with full years, Calendar Auto extends the output to include complete years. True. Date tables created for time intelligence must contain every date within the span. No gaps are permitted. True. Calendar Auto and Calendar always require static start and end dates to be defined manually. False. A calculated date table created with Calendar Auto automatically includes fiscal year-end alignment based on its argument value. True. Let's walk through why each answer makes sense. The first statement is true because Calendar Auto automatically expands the returned range to ensure the date table covers full calendar years, which is essential for accurate time intelligence functions. The second statement is also true since Power BI requires a valid date table to include every single date in the defined range. Any missing dates would break relationships and time-based calculations. The third statement is false, as only the calendar function needs manual start and end dates. Calendar Auto determines these automatically by scanning the dataset. Finally, the fourth statement is true because Calendar Auto can align the output to a fiscal year-end month defined by its numeric argument, ensuring that fiscal reporting stays consistent with business cycles. Altogether, these rules make Calendar Auto a powerful tool for creating complete and compliant date tables with minimal manual setup. Question 21. For each statement, drag the concept it always describes. Each item may be used once, more than once, or not at all. Requires a table and an expression that returns one value per row, iterator functions, x. Single column functions sum, count, min, max are shorthand for their x counterparts. Engine equivalence. Default ranking is descending and skips ranks for ties, rank X default behavior. Dense ranking continues numbering without gaps after ties, rank X with dense argument. Used to make the rank blank on totals by requiring a single product in context, Hasone value usage. Quick tour of why these fit so well. First, iterator functions like SumX take a table and evaluate an expression row by row, therefore they always need both inputs. Meanwhile, engine equivalence means sum behaves like SumX over a single column, so performance and results align accordingly. Next, rank X by default sorts high to low and skips numbers when ties occur. For example, two items tied for first become ranks 1 and 1, then the next is 3 rather than 2. Conversely, adding the dense argument keeps numbering continuous after ties, so those same items would be 1 and 1, and the next becomes 2 instead of 3. Finally, Hasone value enforces a single item in context. Consequently, totals where multiple products exist return blank, which is perfect for rank visuals that should not compute on grand totals. Question 22. For each statement below, indicate whether it is true or false. Iterator functions evaluate an expression row by row, row context. True, complex per row expressions, e.g. quantities, price, 1, nice discount percent, are a common use of SumX. True values sales order, creates a unique list of orders in the current filter context for use by average X. True. The default behavior of rank X is ascending order with dense ties. False. Let's explore why these answers are correct. The first statement is true because iterator functions such as SumX, average X, and rank X apply an expression to each row in a table using row context, which allows per row evaluation before aggregation. The second statement is also true, as iterators are often used for multi-column calculations. For instance, SumX sales quantity, sales price, 1 minus sales discount computes the total revenue per row before summing it up across the table. The third statement is true, since the values function returns a distinct list of the specified column's values, in this case unique order numbers, which can then be used to change the evaluation grain for functions like average X. The final statement is false, because by default, rank X ranks in descending order and skips numbers when there are ties. To achieve dense ranking, no skip numbers, you must explicitly specify the dense parameter. And altogether, these points highlight how DAX iterators handle row-by-row logic, aggregation, and ranking behavior with precision and flexibility. Question 23. Fill in the blanks by selecting the correct options from the drop-down menus. When a DAX expression inside a calculated column references a measure, a context transition occurs automatically, converting row context into filter context. Here's a deeper look at what's really happening. Context transition is a key DAX concept that comes into play whenever a measure is evaluated within a row context, such as in calculated columns or within functions like calculate. This mechanism converts the current row context, which evaluates one record at a time, into a filter context so that the measure can retrieve aggregated results consistent with that specific row. In essence, DAX temporarily applies filters equivalent to the current row's values, allowing the measure to behave as if it were being calculated at a report level rather than purely at the row level. Without this automatic conversion, measures used inside calculated columns wouldn't return meaningful results, since they rely on filter context to evaluate aggregated data rather than individual row values. Question 24. Arrange the following steps in the correct order to describe how filter works when used inside a calculate expression. Instruction. Drag and drop the items into the correct order starting from the first step. A table or table expression is passed to filter. Filter evaluates an expression for each row. Rows that evaluate to true are returned. Calculate applies that table as a new filter context. Let's unpack this step by step. When filter is used inside calculate, the process begins by passing in a table or a table expression as input. Filter then loops through each row, evaluating a logical condition one row at a time. Only the rows where the expression evaluates to true are kept, forming a refined subset of the original table. Finally, calculate takes this filtered subset and uses it to modify the filter context, effectively recalculating the target measure or expression under the new conditions. This sequence ensures that only the rows meeting the logical criteria influence the result, making calculate one of the most powerful and context-aware functions in DAX. Question 25. A company wants to calculate sales commissions, 15% for sales in the United States and 10% for other countries. However, the total commission row in the visual shows blank. What explains this outcome? Select one answer. A. Values returns blank because the country column contains no data. B. Hassone value returns false because multiple countries exist in the total filter context. C. Selected value returns the average of all country values. D. The calculation multiplies the revenue measure by 0. The correct answer is B. Hassone value returns false because multiple countries exist in the total filter context. Let me walk you through it so it clicks. At the grand total level, more than one country is in scope. Therefore, Hassone value country evaluates to false and the measure branches to blank as designed. Meanwhile, values does not imply missing data. It returns a distinct list of countries, so option A does not explain the blank total. Likewise, selected value would return a single value only when exactly one country is in context. Otherwise, it returns blank and it does not average anything, so option C is incorrect. Finally, multiplying revenue by 0 is not part of the logic here. Consequently, option D does not apply. So the blank total appears because the measure correctly detects multiple countries at the total level, and with Hassone value returning false, it withholds a single country commission result. Question 26. For each statement below, indicate whether the answer is true or false. Data analysts spend most of their time working with data rather than visuals. True. Poorly designed DAX expressions can contribute to slow performance. True. Performance optimization is a quick process that requires little planning. False. A well-optimized semantic model supports better reporting performance. True. All right, now let's go through the explanation together. Data analysts primarily dedicate their efforts to data modeling and transformation rather than visuals because the quality of data preparation directly impacts performance and accuracy. Next, inefficient or overly complex DAX expressions can indeed slow down calculations since they require more processing time and memory usage during query evaluation. However, performance optimization is not a quick process. It demands careful planning, iterative testing, and refinement to identify bottlenecks and improve query speed effectively. Finally, when the semantic model is properly optimized, it enables faster report interactions and smoother calculations, making the entire Power BI experience more efficient and responsive. Question 27. A Power BI developer imports several large transactional tables. The report runs slowly and model size is increasing. The developer creates summary tables that aggregate sales by date, customer, and product, then sets large fact tables to direct query. What performance result should they expect? Select one answer. A. Improved performance from smaller model size and optimized direct query design. B. Slower performance because summarized tables increase file size. C. No impact because summarization and direct query cancel each other out. D. reduced accuracy because Power BI disallows aggregation in direct query. The correct answer is A, improved performance from smaller model size and optimized direct query design. Here's why this works. Aggregating to summary tables dramatically reduces the number of rows stored in import, therefore the in-memory model shrinks and scans are faster. Meanwhile, direct query keeps the very large detail tables out of memory and queries them only when necessary, so the model avoids loading millions of granular rows that aren't needed for most visuals. Consequently, report pages render quicker for typical summaries, and only drill-throughs or detailed views hit the source via direct query, which is a balanced design for scale. Options B and C don't hold because summarization lowers, not raises model size, and it complements direct query rather than neutralizing it. Option D is incorrect since aggregation functions are supported with direct query, so accuracy is maintained when relationships and measures are modeled correctly. Question 28. A database administrator is running a large system refresh on the same server used by Power BI direct query reports. Users begin experiencing report delays. What is the most likely cause of the slowdown? Select one answer. A. The semantic model contains too many visuals for Power BI to handle. B. Network bandwidth has automatically throttled due to caching. C. Power BI service has reached its data refresh quota. D. Other workloads on the database server are consuming resources needed by direct query queries. The correct answer is D. Other workloads on the database server are consuming resources needed by direct query queries. Now, let's look at why this happens. When Power BI uses direct query, it depends entirely on the database server's processing power to return query results in real time. If a large system refresh or another heavy workload is running on the same server, it competes for CPU and memory resources, slowing down the response time of direct query requests. Therefore, even though the Power BI report itself may be optimized, the underlying database contention causes delays. Options A, B, and C are incorrect because the number of visuals or data refresh limits do not directly affect direct query latency, and network caching doesn't throttle performance in this scenario. In essence, when the server is busy with other tasks, direct query performance drops because it shares the same hardware resources. Question 29. To support relationships reliably, which preparation step in Power Query is essential when the source uses multi-column keys? Select one answer. A. Add an index column to every table. B. Convert all key columns to text regardless of original type. C. Leave keys as multi-column. Power BI will combine them automatically. D. Transform data to produce single-column keys in related tables. The correct answer is D. Transform data to produce single-column keys in related tables. Here's why this is the right choice. Power BI relationships are always defined on single columns, so when a source table relies on composite or multi-column keys, you must first combine those columns in Power Query to form one unique key column. This ensures consistent joins between tables, preventing mismatched relationships and data duplication. For example, if a sales table identifies orders using both order ID and region code, you could merge them into a new column like order key equals order ID and NAIS and region code before loading it into the model. Options A and B are not required. An index doesn't help with relationships unless used for modeling, and changing all keys to text is unnecessary as long as data types match. Option C is incorrect because Power BI won't automatically combine multi-column keys for you. You must prepare them manually during data transformation. Question 30. A report designer creates a DAX measure that calculates average sales. When the user filters the report to show a single region, the measure result changes to a smaller value. What can be said about the data type of this measure? Select one answer. A. The measure's data type is fixed as text when created. B. The measure's data type can change depending on the result of the calculation and applied filters. C. The measure's data type must always be integer. D. The measure's data type cannot be affected by filters once defined. The correct answer is B. The measure's data type can change depending on the result of the calculation and applied filters. Now let's understand why this happens. In DAX, a measure's data type is determined dynamically based on its evaluated result rather than being permanently fixed. When filters are applied to a report, such as narrowing data to a specific region, the calculation context changes, which can alter the measure's output type or precision. For example, when calculating an average across all regions, the result may be a large decimal number, but filtering to one region could yield a smaller or differently formatted result. Unlike columns, measures don't store data. They evaluate on the fly depending on filters and context. Therefore, filters can indirectly influence the measure's data type because they affect how DAX computes the final result. Question 31. What is the valid numeric range for a whole number data type in DAX? Select one answer. A, 0 through 1 million. B, negative 2 to the power of 63 through 2 to the power of 63 minus 1. C, negative 9.2, 2 times 10 to the power of 14 through 9.2, 2 times 10 to the power of 14. D, negative 1.79 times 10 to the power of 308 through 1.79 times 10 to the power of 308. The correct answer is B. Here's why this is correct. In DAX, the whole number data type corresponds to a 64-bit signed integer, which means it can represent values from negative 2 to the power of 63 all the way up to positive 2 to the power of 63 minus 1. This large range supports both very small and extremely large whole values, making it suitable for handling counts, identifiers, or other integer-based calculations. On the other hand, options like 0 to 1 million are far too narrow and arbitrary. The range negative 9.22 times 10 to the power of 14 through 9.22 times 10 to the power of 14 actually applies to the currency data type, while negative 1.79 times 10 to the power of 308 through 1 times 10 to the power of 308 belongs to the decimal number type, which supports floating point values. So whenever you define a column or measure as a whole number in DAX, remember it's powered by a 64-bit integer capable of storing values within the range of negative 2 to the power of 63 through 2 to the power of 63 minus 1. Question 32. When you add a numeric field to a visual that supports aggregation, how does Power BI handle it by default? Select one answer. A. It automatically creates an implicit measure and summarizes the field based on the default aggregation type. B. It displays each row's individual value without any summarization. C. It prompts the user to manually select an aggregation before displaying results. D. It creates a DAX formula measure automatically in the model. The correct answer is A. It automatically creates an implicit measure and summarizes the field based on the default aggregation type. Now let's break this down. In Power BI, when you drag a numeric field like sales or revenue into a visual, say a table or chart, the system automatically summarizes it according to the default aggregation type, usually sum. This automatic behavior is known as creating an implicit measure, which means the aggregation exists only within that specific visual. It's not stored permanently in the data model. For example, if you drop a quantity column into a bar chart, Power BI will instantly add up the quantities per category without asking you to define the aggregation manually. If you want to change this behavior, you can adjust the summarization setting to Don't Summarize or switch to other aggregations like average, min, or max. So by default, Power BI helps users quickly visualize data by summarizing numeric fields automatically through an implicit measure. Question 33. An analyst uses a running sum visual calculation on a matrix showing sales amount by year, quarter, month. They want the running sum to restart for every year. Which configuration meets this requirement? Select one answer. A. Running sum, sales amount minus 1. B. Running sum, sales amount. C. Running sum, sales amount, lowest parent. D. Running sum, sales amount, highest parent. The correct answer is D. Running sum, sales amount, highest parent. Let's break it down step by step. The highest parent parameter in the running sum function specifies that the running total should reset whenever the top-level grouping, in this case, the year, changes. This means that each year will have its own independent cumulative total, ensuring that the sum restarts fresh for every new year in the matrix. If we had used lowest parent, the running sum would reset at the quarter level instead of the year, which doesn't meet the requirement. Without a reset parameter, such as in option B, the sum would continue accumulating across all years, never restarting. And option A, using NICE1, would reset based on row context rather than by grouping level, producing inconsistent results. In essence, using highest parent ensures that the calculation correctly restarts at the top hierarchy level, perfect for visualizing yearly running totals in Power BI. Question 34. Performance optimization is also known as what? Select one answer. A. Performance tuning. B. Data cleansing. C. Visual refinement. D. Data storytelling. The correct answer is A. Performance tuning. Here's how to understand it. The term performance tuning is often used interchangeably with performance optimization because both refer to the process of improving efficiency, speed, and responsiveness in semantic models or Power BI reports. Essentially, performance tuning means identifying bottlenecks, whether in DAX formulas, model design, or data loading, and making adjustments that enhance overall performance. By contrast, data cleansing deals with correcting or removing inaccurate or inconsistent data, which affects accuracy but not necessarily performance. Visual refinement focuses on improving report aesthetics or layout, not computational speed. And data storytelling is about presenting insights effectively, emphasizing narrative and clarity rather than processing efficiency. So in the context of Power BI and data modeling, performance tuning is indeed another name for performance optimization. Question 35. Which statement about cross-filter direction is aligned with best practice? Select one answer. A. Single direction filters never allow dimension-to-fact propagation. B. Cross-filter direction only matters for many-to-many relationships. C. Prefer both directions wherever possible for convenience. D. Avoid or minimize both direction cross-filters for performance and clarity. D. Avoid or minimize both direction cross-filters for performance and clarity. Here's the reasoning. In Power BI data modeling, single direction relationships from dimension to fact table are the standard and most efficient configuration. They maintain a clear flow of filter context and prevent circular dependencies. When bidirectional filters are used, Power BI must resolve filters from both sides of a relationship. While this can be useful in rare cases, such as complex many-to-many relationships, it often introduces ambiguity, slower query performance, and increased complexity in debugging filter propagation. Best practice recommends using bidirectional filters sparingly and only when absolutely necessary to preserve model clarity and efficiency. Option A is incorrect because single direction filters do allow normal dimension to fact propagation. That's their intended behavior. Option B is too narrow. Cross-filter direction affects more than just many-to-many relationships. Option C is wrong because preferring both directions for convenience harms model transparency and can degrade performance. In summary, the best practice is to limit bidirectional cross-filters to specific scenarios and otherwise favor single-direction filters for optimal performance and model clarity. Question 36. Which statement correctly describes how operator precedence affects a DAX formula? Select one answer. A. All operations are evaluated from right to left. B. Operators are evaluated based on fixed priority levels and equal precedence operators process left to right. C. Parentheses are ignored when determining operator order. D. Operator precedence changes based on data type. The correct answer is B. Operators are evaluated based on fixed priority levels, and equal precedence operators process left to right. Let's understand why. In DAX, operator precedence defines the order in which parts of an expression are evaluated. Each operator, like plus, minus, slight, etc., has a fixed priority level that determines when it is executed relative to others. For example, multiplication and division are performed before addition and subtraction, just like in standard arithmetic. When two operators share the same precedence level, DAX evaluates them from left to right, maintaining logical and predictable behavior. Parentheses, however, can override this precedence. They always take the highest priority, allowing explicit control over the calculation order. Option A is incorrect because DAX evaluates from left to right, not right to left. Option C is wrong because parentheses are never ignored. They directly control the evaluation sequence. Option D is also incorrect since precedence is constant and doesn't depend on data types. So DAX follows a structured rule, fixed operator priority, with equal precedence operators processed left to right, ensuring consistent formula evaluation. Question 37. You are a Power BI developer at a company where report users complain about slow performance when pages load and filters are applied. The IT team reports that the semantic model file size is very large and is consuming excessive memory resources. Which action would most directly improve the situation? Select one answer. A. Optimize visuals by reducing chart elements. B. Review and minimize model size by removing unnecessary data. C. Change the report theme and formatting for faster rendering. D. Add calculated columns for user convenience. The correct answer is B. Review and minimize model size by removing unnecessary data. Now let's go through the explanation together. When your Power BI model becomes very large, it directly impacts memory usage and slows performance during report refreshes and filtering. The most effective solution is to reduce the size of the semantic model by removing unnecessary data. For instance, if you're importing entire historical tables but only need the last 2 years of data, trimming those extra rows can drastically reduce model size and improve performance. On the other hand, optimizing visuals by reducing chart elements might make the page slightly lighter, but it doesn't fix the underlying issue of memory consumption. Similarly, changing the report theme or formatting only affects appearance, not how efficiently Power BI handles data. Adding calculated columns instead of helping actually increases model size and slows things down further. So, the best course of action is to review and minimize your model by removing unnecessary data, ensuring your reports run faster and consume less memory overall. Question 38. For each report design principle, drag it to its correct description in the correct match column. Each item may be used once, more than once, or not at all. Ensures the report page has clear margins and balanced object spacing to avoid clutter. Space relates to page size and visual size. Larger visuals draw more focus. Size keeps visuals and sections properly lined up with even spacing, alignment. Uses limited, meaningful colors with strong contrast for accessibility. Color promotes uniform fonts, sizes, and styles, often achieved with themes. Consistency. Now let's go through the explanation together. The first match, space, focuses on how margins and balanced spacing reduce visual clutter, creating room for the eye to rest and improving readability. Next, size draws attention to the relative scale of visuals. Larger visuals signal higher importance, while equal sizing suggests related content. Moving on, alignment ensures that visuals and sections are neatly lined up, helping users follow the flow of information naturally. After that, colors should be used with purpose. Limited palettes and high contrast not only enhance aesthetics, but also ensure accessibility for all viewers. Finally, consistency ties everything together by maintaining uniformity across fonts, spacing, and styles, which helps create a professional and cohesive look throughout the report. Together, these design principles ensure reports are visually appealing, easy to read, and accessible to all users. Question 39. For each statement below, indicate whether the answer is true or false. Row-level security can cause blank results for users without access to specific data. True. Reports can override row-level security filters when needed. False. Page-level filters restrict data across all visuals on that page only. True. Visual-level filters affect only the data displayed in the specific chart or visual. True. Now let's go through the explanation together. Row-level security, often called RLS, hides restricted data from users who don't have permission to see it. As a result, visuals that depend on that data may show as blank, which is why the first statement is true. However, reports themselves cannot override RLS because it's applied at the semantic model level, meaning it's enforced by Power BI and cannot be bypassed by report designers. Moving on, page-level filters apply to every visual on a given report page. For example, if you filter a page to show data for a single region, all visuals on that page will only display data from that region. Finally, visual-level filters are even more specific. They apply only to the individual chart or table they're set on. This helps designers customize what each visual displays without affecting others. Together, these filtering mechanisms ensure both data security and contextual control across Power BI reports. Question 40. Fill in the blanks by selecting the correct options from the drop-down menus. When choosing between filters pane and slicers, consider that the filters pane offers advanced filter types like top N and better performance since it avoids rendering visuals, while slicers provide on-page visibility of selections and can display images when a field is categorized as an image URL. All right, let's break this down step by step. The filters pane is designed for precision and performance. It supports advanced filter types such as top N, relative date, or conditional filters. Because it doesn't render visuals like slicers do, it performs faster and uses fewer system resources, making it ideal for complex or large data sets. Meanwhile, slicers shine when interactivity and user visibility matter. They display filter selections directly on the report canvas, allowing users to see what's currently applied. This is especially helpful in dashboards meant for quick data exploration. Moreover, slicers can display images, which is perfect for fields like product photos, employee pictures, or brand logos. In essence, filters maximize performance and precision, while slicers enhance clarity and user engagement. Question 41. Fill in the blanks by selecting the correct options from the drop-down menus. The guided analytical experience allows users to move from high-level metrics to supporting visuals and then to details, only when needed. Let's unpack the reasoning behind this step by step. A guided analytical experience is built to lead users through information in a logical, meaningful flow. It begins with high-level metrics, which act as the entry point, providing a quick summary or snapshot of overall performance. For instance, a dashboard might show total sales, customer satisfaction, or profit margins at a glance. This helps users orient themselves before exploring deeper layers. Next, supporting visuals come into play. These visuals give context to those top-level numbers by highlighting trends, comparisons, or correlations. For example, line charts or bar graphs may reveal performance over time or across regions, helping users understand why those high-level metrics look the way they do. Finally, when users need more granularity, they can move to details, which show specific records or transactional data. This stage answers precise questions such as which product underperformed or which customer segment contributed most. So this guided flow from summary to context to detail ensures clarity, efficiency, and a smooth analytical journey. Question 42. For each statement below, indicate whether the answer is true or false. Conditional formatting can use data bars or icons to emphasize important values. True, it's acceptable to rely only on color for highlighting because all users can perceive color differences. False. Overlaid analytics can add constant lines and minimum or maximum markers to a chart. True. Anomaly detection works on visuals with categorical fields on the x-axis. False. Let's walk through the reasoning behind these answers. Starting with conditional formatting, it's true that Power BI allows the use of data bars, colors, and icons to make key values stand out visually. These tools help convey magnitude, direction, or status instantly, enhancing data readability without needing extra labels. Next, the statement about relying only on color is false. Not every user can distinguish color differences, especially those with color vision deficiencies. That's why good report design incorporates icons, shapes, or textures alongside colors to ensure accessibility and clarity for all audiences. Moving on, overlaid analytics such as constant lines or min-max markers are indeed true. They help users identify thresholds, averages, or performance boundaries at a glance, making the chart more insightful and contextual. Finally, the claim that anomaly detection works with categorical x-axis fields is false. Anomaly detection requires time series data, that is, fields with a date or time component, to recognize deviations or unusual patterns over time. Altogether, these principles emphasize clarity, accessibility, and analytical depth in Power BI visual design. Question 43. For each concept, drag it to the correct description. Each item may be used once, more than once, or not at all. Feature that generates automated insights for a selected data point. Analyze. Action that opens available analysis options. Right-click on a data point. Option that explains why a value rose compared to others. Explain the increase. Option that highlights segments that differ from the overall distribution. Find where the distribution is different. Symbol used to add the new visual to a report, plus plus icon. Condition under which the feature doesn't function. Non-numeric or measure filters applied. Now let's walk through how each concept works in Power BI. The Analyze feature automatically inspects a chosen data point and generates AI-driven insights. It identifies key factors contributing to performance changes or deviations, helping users uncover hidden relationships in data. To activate this feature, you must right-click on a data point. This opens a context menu that includes analysis options such as Explain the increase or Find where the distribution is different. The Explain the Increase option provides a clear, visual explanation of why a metric rose, showing which elements or dimensions contributed most to that growth. On the other hand, Find where the distribution is different helps detect unusual patterns or segments within your data that differ significantly from the overall trend. The plus plus icon allows you to add any AI-generated visual directly into your report for continued use or presentation. Finally, remember that the feature won't operate when non-numeric or measure filters are applied, since the analysis depends on numerical data for statistical accuracy. Altogether, these tools enhance interactivity, insight generation, and automation within Power BI reports. Question 44. Designers are optimizing a report for phones and small tablets. Which two adjustments are recommended? Select two answers. A. Pack many visuals on each page to avoid extra navigation. B. Rely on mouse over tooltips as the primary interaction. C. Default to landscape and small fonts to fit more content. D. Use fewer and less complex visuals per page. E. Increase visual size and spacing for readability and touch. The correct answers are D and E. All right, now that we've gone through the question and the correct answers, let's move on to the explanation. When designing for phones and small tablets, the key is to optimize for clarity and touch interaction. Using fewer and less complex visuals per page helps reduce clutter and makes it easier for users to focus on the main insights without feeling overwhelmed. Small screens have limited space, so simplicity improves usability and comprehension. Moreover, increasing visual size and spacing enhances readability and touch accuracy. On mobile devices, users rely on their fingers rather than a precise cursor, so larger elements make it easier to interact with buttons, filters, and visuals. For example, think about a Power BI dashboard viewed on a smartphone. If it's crowded with charts and small fonts, the user will struggle to tap or read values. But when visuals are simplified and given enough space, the experience becomes smoother and more intuitive. In short, minimal visuals and larger spacing together create a cleaner, more user-friendly design for smaller devices. Question 45. Arrange the steps of a typical drill-through interaction in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Correct order. Open and view the summary report page. Identify a specific visual element to analyze in depth. Right-click the chosen element to drill through. Perform complementary analysis on the destination page. Return to the source summary page. I'll briefly explain why this sequence works so well. First, you open the summary page because it provides the big picture and helps you notice where to investigate further. Next, once a chart or data point stands out, you identify that specific visual so the drill through has a clear target. Then you right-click the element. This action triggers navigation to the detailed destination page where context about that item is already filtered in. After landing there, you perform complementary analysis, such as reviewing related metrics, applying filters, or comparing time ranges to uncover causes and patterns. Finally, you return to the source summary page to continue scanning other areas or to validate your findings in the original context. Question 46. A report designer creates a Power BI report where users can drill through to a detailed page. However, users struggle to find their way back to the main page after drilling through. What should the designer do to fix this? Select one answer. A. Add navigation buttons only on the main page. B. Add a left-pointing back button on the drill-through page. C. Enable tooltips on visuals to guide users. D. Change the button hover color to make it more visible. The correct answer is B. Add a left-pointing back button on the drill-through page. Now let's go over why this is the best solution. Adding a left-pointing back button gives users a simple, familiar way to return to the main report after exploring a detailed drill-through page. It improves navigation flow by reducing confusion, especially when users move between multiple layers of data. Think of it like a back arrow in your browser. It provides a consistent path for returning to the overview without breaking focus. Adding navigation buttons only on the main page won't help since users are already on the drill-through page and need a way back. Tooltips can explain actions but don't actually perform navigation, and changing a button's hover color only affects visibility, not functionality. So the back button remains the most intuitive and practical fix for seamless navigation within Power BI reports. Question 47. A manager wants to identify the 10 worst performing products by cost of sales directly in a visual, no DAX required. Which configuration meets the need in the filters pane? Select one answer. A. Choose top N, set top equals 10, and use cost of sales as the by value. B. Choose bottom N, set bottom equals 10, and use cost of sales as the by value. C. Choose relative date, set last 10 days, and use cost of sales. D. Choose advanced filtering, include values less than 10. The correct answer is B. Choose bottom N, set bottom equals 10, and use cost of sales as the by value. Let's explore why this is the right setup. When identifying the worst performers, you're essentially looking for the lowest values within a measure, in this case, cost of sales. The bottom N filter allows you to automatically return the lowest performing items based on a chosen metric without the need to write DAX formulas. If you had chosen top N, it would return the best performers, not the worst. Relative date filtering wouldn't help because it's designed for time-based analysis rather than ranking measures. And advanced filtering using numeric thresholds wouldn't rank or sort items. It would just exclude values outside a set range. Therefore, the bottom N configuration is the most efficient way to pinpoint underperforming products quickly within Power BI visuals. Question 48. When you first build a visual in Power BI, what happens to the underlying data and how can you adjust the way groups appear? Select one answer. A. Power BI automatically filters, groups, and summarizes data for the visual. You can refine presentation by creating your own groups or bins. B. Power BI shows raw rows without aggregation. Groups and bins are applied only by the data source. C. Power BI requires a DAX measure before any grouping or summarization is possible. D. Power BI disables grouping in visuals. Only model-level hierarchies can control presentation. The correct answer is A. Power BI automatically filters, groups, and summarizes data for the visual. You can refine presentation by creating your own groups or bins. Let's unpack this concept clearly. When you create a visual in Power BI, the tool automatically performs basic summarization, aggregating data such as sums, averages, or counts depending on the field type. This built-in functionality ensures that visuals display meaningful summaries rather than raw, unstructured rows. You can then enhance or refine this presentation by defining custom groups or bins, giving you more control over how categories or numeric ranges are displayed. If Power BI showed only raw data, the visual would lose its analytical value. Similarly, requiring a DAX measure before summarization would slow down exploration since automatic aggregation happens by default. And disabling grouping entirely would contradict Power BI's flexibility in visual customization. Therefore, automatic summarization with optional custom grouping makes Power BI both user-friendly and analytically powerful. Question 49. Which two statements about drop-down slicers are true? Select two answers. A. They can't be used with date fields. B. They always filter the entire report. C. They save page space compared to list slicers. D. They query the semantic model only when expanded. E. They eliminate the need for the filters pane. The correct answers are C. They save page space compared to list slicers. And D. They query the semantic model only when expanded. Let's dive into why these two options are right. Drop-down slicers in Power BI are designed to reduce visual clutter by collapsing the list of filter options into a compact drop-down format. This helps conserve page space, especially on dashboards where multiple slicers are needed. It enhances usability while maintaining filtering functionality. Additionally, drop-down slicers only query the semantic model when expanded. This behavior improves page load performance, since the data query runs only when users interact with the slicer, rather than continuously fetching results in the background. By contrast, the incorrect statements don't hold up. Drop-down slicers can be used with date fields. They don't always filter the entire report since scope depends on placement, and they don't replace the filters pane but rather complement it. In summary, drop-down slicers are efficient both visually and technically, offering cleaner layouts and optimized performance. Question 50. You need to segment customers by behavior using 4 different measures, and you want a consistent number of clusters across pages. What should you do? Select 2 answers. A. Use a table visual, add all required fields, then run automatically find clusters. B. Open the clusters window and enter your desired number of clusters before confirming. C. Create manual group data categories to represent the clusters. D. Apply new group in the data pane with a bin size to force equal ranges across measures. E. Rely on a single scatter chart and add each measure to the axes sequentially. The correct answers are A. Use a table visual, add all required fields, then run automatically find clusters, and B. Open the clusters window and enter your desired number of clusters before confirming. Let's look at the reasoning behind these selections. When segmenting customers by multiple measures, Power BI's clustering feature allows you to automatically identify groups of similar behavior patterns without manual classification. The table visual is particularly suitable here because it supports clustering with more than 2 measures, unlike a scatter chart which can only handle 2 axes. After adding the necessary fields, running. Automatically find clusters initiates the clustering algorithm to group customers based on similarities. Opening the clusters window and specifying a number ensures consistency in the number of clusters across different report pages or visuals. This control is essential for maintaining analytical uniformity throughout your report. In contrast, creating manual groups or bins doesn't perform true clustering. It merely segments data by static value ranges. Thus, the correct approach combines Power BI's built-in clustering with controlled cluster count settings for precise, repeatable segmentation. Question 51. For each Power BI service component, drag it to the correct description in the correct match column. Each item may be used once, more than once, or not at all. Organizes and manages Power BI content such as reports and semantic models. Workspaces enables users to interact with visuals directly in a browser. Reports serves as a certified data source ready for creating reports. Semantic models provides a single-page visual summary that can combine multiple data sources. Dashboards groups related content like dashboards and reports for distribution to larger audiences. Apps. Now let's explain everything step by step. Workspaces are where users organize, manage, and collaborate on Power BI content like reports, dashboards, and semantic models. Think of them as shared folders where teams build and publish their analytics projects together. Next, reports let users interact with visuals and filters directly in the browser. For instance, a sales manager might click on a region in a chart to instantly view performance details. Then we have semantic models, which define structured data, including relationships and measures. These act as certified, reusable data sources that maintain consistency across multiple reports. Moving on, dashboards provide a one-page summary of insights by combining visuals from various reports. They help executives get a quick snapshot without opening every report individually. Finally, apps group related dashboards and reports for easy distribution across departments. They're especially useful when sharing curated analytics experiences with larger audiences. So the key takeaway is that each Power BI component has a unique role, from organizing content to presenting insights, all working together to make data analysis efficient and accessible. Question 52. For each statement below, indicate whether it is true or false. Reports can be uploaded directly to a workspace using the Power BI service. True. Publishing from Power BI Desktop automatically includes the semantic model, true. Uploading via the Power BI service requires that all users have a premium license, false. Reports in OneDrive for work or school can automatically sync to Power BI approximately once an hour, true. Let's now go through the reasoning behind each of these statements. First, it's true that reports can be uploaded directly to a workspace using the Power BI service. You can upload a .pbx file straight into a workspace online, which makes report sharing and management much easier. Next, publishing from Power BI Desktop automatically includes the semantic model is also true. When you publish a report, the associated data model, tables, relationships, and measures is deployed automatically, ensuring consistency between desktop and service environments. Then, the statement that uploading via the Power BI service requires that all users have a premium license is false. Premium capacity is optional. Users with a Pro or Premium per user license can still upload and share reports depending on workspace settings. Finally, reports in OneDrive for work or school can automatically sync to Power BI approximately once an hour is true. Power BI regularly checks for updates in connected OneDrive or SharePoint folders, refreshing reports automatically without manual intervention. In short, these behaviors make Power BI's integration with both local and cloud environments seamless, making collaboration and report maintenance highly efficient for any organization. Question 53. Fill in the blanks by selecting the correct options from the drop-down menus. Incremental refresh in Power BI uses two date time parameters named range start and range end to control the sliding data window that determines which data is refreshed or retained. Let's unpack how this works to understand why these are the correct answers. Range start defines the beginning boundary of the data to import and refresh. For example, if you set range start to January 1st, Power BI will begin loading data from that date onward. Meanwhile, range end sets the upper boundary, determining the most recent date up to which data is refreshed. This creates a controlled window for incremental updates rather than reloading everything. Together, these parameters define what's called a sliding data window. This window moves forward over time, automatically including new data while discarding old data that falls outside the defined range. In real-world terms, imagine a sales dashboard that only needs data from the last 12 months. Instead of reprocessing years of records each time, Power BI uses range start and range end to refresh just that recent period. This approach makes refreshes much faster and more efficient, ensuring that large data sets remain manageable while always showing the latest information. Question 54. For each statement below, indicate whether the answer is true or false. Q&A can only be used by Power BI developers in desktop, false. Q&A generated visuals can be pinned to dashboards, true. Q&A replaces the need for all pre-built reports, false. Pre-populated tiles in Q&A help users phrase questions, true. Let's go through the explanation together and understand why each statement is correct. First, the claim that Q&A can only be used by Power BI developers in top is false. Q&A is available to all dashboard users in the Power BI service, not just report creators or developers. This means anyone with access can type natural language questions and instantly generate visuals. Next, Q&A generated visuals can be pinned to dashboards is true. Once a user creates a visual through the Q&A interface, they can easily pin it to a dashboard to monitor key metrics over time. This allows users to turn their ad hoc insights into reusable visuals. The third statement, Q&A replaces the need for all pre-built reports, is false. Q&A complements traditional reports but doesn't replace them. While Q&A is great for quick insights, pre-built reports still provide structure, formatting, and governed analysis that Q&A doesn't fully replicate. Lastly, pre-populated tiles in Q&A help users phrase questions as true. These tiles provide sample queries that guide users on how to ask effective natural language questions. It's a helpful feature for those new to Power BI's Q&A experience. In short, Q&A is designed to empower all users, not just developers, by making data exploration conversational, intuitive, and interactive. Question 55. Fill in the blanks by selecting the correct options from the drop-down menus. Quick Insights in Power BI runs on imported data in the Power BI service and uses machine learning algorithms to identify patterns and generate visuals. Now let's unpack this step by step to understand how it works. First, Quick Insights operates on imported data, meaning the dataset must be loaded directly into Power BI rather than using direct query connections. This is because the analysis requires access to stored data for computation and pattern detection. Next, it runs in the Power BI service, not in Power BI Desktop. The feature is available in the online environment, allowing users to quickly explore datasets and uncover insights without needing to write queries or build visuals manually. Finally, it relies on machine learning algorithms to detect trends, correlations, and anomalies automatically. These algorithms scan the data to identify meaningful relationships and then visualize them in an easy-to-understand format. In a real-world scenario, imagine uploading a sales dataset into Power BI service. With a single click, Quick Insights can reveal which regions are overperforming, which products drive the most revenue, or where sudden changes in trends occur. Overall, Quick Insights makes data exploration faster and smarter, helping users move from raw data to actionable insights in seconds. Question 56. Arrange the following steps to pin a live report page to a Power BI dashboard in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. 1. Open the desired report in Power BI service. 2. Select the ellipsis on the navigation bar. 3. Choose Pin to a dashboard. 4. Select the target dashboard. 5. Select Pin Live to create the live connection. Now, let's walk through why this sequence makes sense. To begin, you must open the desired report in Power BI service, since that's where the pinning action takes place. Once the report is visible, you select the ellipsis on the navigation bar to reveal more report options. After that, you choose Pin to a dashboard. This is the command that starts the process of linking your report page to a dashboard. Then you select the target dashboard, specifying where the live visual will appear. Finally, you select Pin Live to create the live connection, which ensures that the dashboard tile updates automatically whenever the report visuals change. In practice, this feature is extremely useful for keeping dashboards dynamic. For example, a sales manager can pin a live report showing daily revenue trends, and the dashboard will always reflect the most recent data without needing manual refreshes. Question 57. A Power BI designer needs to share several dashboards and reports with hundreds of employees across the organization. However, not all employees should have edit rights to the workspace. Which feature allows the designer to distribute content broadly while maintaining control? Select one answer. A. Workspaces. B. Apps. C. Dashboards. D. Semantic models. The correct answer is B. Apps. All right, let's take a moment to explain this together. Apps in Power BI are a powerful way to distribute content widely across an organization while keeping editing rights limited to only those who manage the workspace. When a designer publishes dashboards and reports as an app, all users can view and interact with them, but they cannot modify or delete anything. This setup helps maintain both control and consistency across large teams. On the other hand, workspaces are mainly for collaboration among report creators and developers. Everyone in a workspace typically has editing privileges, so it's not ideal when you want restricted access. Similarly, dashboards simply display data summaries and don't control sharing permissions. And semantic models focus on defining data relationships and measures rather than distributing content. For instance, imagine a sales analytics team publishing an app that provides executives access to company-wide sales performance dashboards. Those executives can view insights anytime without risking accidental edits. That's how Power BI apps help maintain both accessibility and control across an organization. Question 58. What is a unique advantage of certified Power BI content compared to promoted content? Select one answer. A. Certified content disables sharing permissions for viewers. B. Certified content automatically applies a sensitivity label. C. Certified content can only be viewed in Power BI Desktop. D. Certified content appears higher in search results for users. The correct answer is D. Certified content appears higher in search results for users. All right, let's unpack this one step at a time. Certified content in Power BI is special because it carries a formal approval, usually from a data governance or admin team. This approval tells users that the content has been validated as accurate, reliable, and trustworthy. As a result, Power BI automatically prioritizes this certified content in search results, making it easier for users to find and rely on high-quality data sources. Meanwhile, promoted content is content that creators or teams endorse informally. It's still discoverable, but it doesn't have the same level of authority or search priority as certified content. Now, the other options are incorrect for clear reasons. Certification doesn't disable sharing permissions, nor does it apply sensitivity labels automatically. And it's certainly not limited to Power BI Desktop, since certified content is accessible across both desktop and service. To put it in perspective, imagine you're working in a large organization with hundreds of data sets. When you search for financial report, Power BI places the certified version at the top, ensuring you're using the trusted official data source instead of one that might have errors or inconsistencies. Question 59, identify two accurate characteristics of Power BI dashboards. Select two answers. A, they are highly interactive with filtering and drill through. B, they can contain visuals from multiple reports. C, they are created in Power BI Desktop. D, they show a high-level overview on a single page. The correct answers are B, they can contain visuals from multiple reports, and D, they show a high-level overview on a single page. All right, let's explore why these two are correct. Power BI dashboards serve as a consolidated view that brings together visuals from multiple reports. This means users can monitor different data sets all in one place without switching between reports. For example, a sales manager can pin tiles from both the sales performance report and the customer satisfaction report onto one dashboard to get a unified snapshot of the business. Furthermore, dashboards are designed to display a high-level overview on a single page, making them ideal for executive summaries and ongoing performance tracking. Unlike reports, which offer deeper interactivity with filters and drill-throughs, dashboards focus on providing a quick, top-level view. Now, the incorrect options help clarify the distinction. Dashboards are not created in Power BI Desktop. They are built within the Power BI service. And while dashboards display visuals, they don't support advanced interactions like drill-through or detailed filtering. That's what reports are for. In essence, think of a Power BI dashboard as the command center of insights. It lets you glance at everything important in one place without the clutter or complexity of multiple reports. Question 60. A company's executive dashboard displays financial visuals sourced from multiple Power BI reports across departments. Which capability of dashboards makes this possible? Select one answer. A, they automatically merge all data sets into one model. B, they convert reports into interactive pages. C, they require each report to use the same semantic model. D, they can display visuals from different reports in one view. The correct answer is D. They can display visuals from different reports in one view. Let's take a closer look at why this is true. Power BI dashboards are designed to bring together information from multiple reports into a single unified view. This capability is what makes dashboards so powerful for executives and decision makers who need to monitor performance across departments at a glance. For instance, a CFO might view a financial summary tile from the finance report, a sales performance chart from the sales report, and an HR turnover metric, all side by side on the same dashboard. Now let's clear up the misconceptions. Dashboards don't merge all datasets into one model. Each visual remains connected to its original dataset. They also don't convert reports into interactive pages because dashboards are static by nature. They're meant for monitoring, not for detailed exploration. Finally, dashboards don't require reports to use the same semantic model, meaning visuals from completely different datasets can coexist on one dashboard. Dashboards serve as the single pane of glass for viewing insights from multiple reports simultaneously. This is what makes them such a vital tool for executive overviews and cross departmental decision making.